Here's my design for a mechanical apparatus that will attach to the wellhead and couple it to a new riser pipe. Here is a simple iris mechanism. It consists of two rings and a set of metal blades. The bottom ring rotates against the top ring and the blades close in. Here's an actual iris from a large format camera. I propose a very large iris be built, 8 to 10 feet in diameter. Here's how the very large iris ring will work. The bottom ring will rotate using a worm gear powered by a pneumatic motor. The gear is machined into the side of the ring. The ring does not need to rotate more than about 70 degrees to close the blades, so the gear is a lot shorter than the circumference of the ring. Here is what the iris blades might look like. There is a pivot point on each end that's made up with a ring. The top ring has a slot so that the pivot can travel. The iris can be made with as few as 4 blades. And here is the assembly. The iris assembly slides into a large steel cylinder housing. The top ring is welded or bolted into place. A retaining ring is welded or bolted into place to support the rotating bottom iris ring. Here's the pneumatic motor mounted on the side of the housing. The housing has a cutout to expose the ring gear and allow the motor, worm, and gear to mate. There are 3 large windows in the housing to allow the oil plume to escape. And here is how the first part of the system works. The cylinder housing is lowered over the cut-off riser pipe and wellhead. Robotic submersibles with cameras will help align the housing so that the iris will close under the flange of the cut-off riser. When the iris is at the necessary position, compressed air will power the pneumatic motor and actuate the bottom iris ring. The blade will close, center up on the wellhead, and clamp down under the flange. Now that the first part of the process is complete, we have a firm platform for the next process. Here, in this diagram, you can see inside the cylinder housing 3 jack screws linked together at the top by a chain. The jack screws are rotated by a pneumatic motor with chain drive, also mounted on the top. When rotated, the jack screws will lower a heavy platform. Connected to the platform is the new riser pipe. The riser pipe slides through a sleeve on top of the housing and through a hole in the jack screw platform and welded or bolted into place. On the end of the riser pipe, protruding through and under the platform, is a malleable metal tapered bushing. When compressed air is supplied to the motor, the jack screws lower the platform and drive the tapered bushing into the cut-off riser pipe. The force between the iris and the platform seat the bushing and create a strong seal. When the air supply is cut off, the jack screws cannot reverse, thus maintaining a tight coupling of all components. Note the cylinder housing in the diagram is probably taller than necessary. The travel of the platform may only need to be a couple of feet to do the job. Now we have a new riser pipe firmly coupled to the wellhead, rising to the ocean surface. Here is the iris coupling mechanism attached to a new blowout preventer. With the old blowout preventer cut away from the wellhead casing and removed from the area, a new blowout preventer can be attached to the iris coupling mechanism with support structures and lowered by cables from the ocean surface. The support structure is comprised of 3 vertical, round, or square beams with jack screw leveling pods on the bottom. The new blowout preventer and iris coupler have rollers attached. When the unit is lowered, the iris coupler is below the pods of the support structure. When it is properly located, the iris will close, centering up the wellhead and clamping down. Then the support structure is lowered to the ocean floor. Sensors in the structure will determine if it needs leveling, and the screw jacks will be activated. Once level, the rollers on the iris coupler will be locked into place. Then inside the iris coupler housing, the jack screw platform with blowout preventer attached will lower and press the malleable metal bushing into the top of the cut-off pipe. The rollers on the top of the blowout preventer can then be locked to the support structure. The iris coupler can also be used to plug the wellhead casing pipe by installing a large malleable metal plug underneath the jack screw platform.